Hello everyone, I'm very pleased to be here. Today I'm going to attempt and put forward to you a new way of viewing the class hierarchy in D. So the way I view it, this is my elevator pitch towards you. The catch is the elevator is only going to take 20 minutes to get to the destination. So let's get going. First, let's talk a bit about the current situation. So as I'm sure all of you here already know, in the D programming language, we have object as the root of all objects. And the main interest of us is that object defines 4 methods. It has toString, toHash, opCompare, and opEquals. And I'm pretty sure that at first they don't strike you with much, but the issue with those 4 is that they predate the introduction of function attributes. So they predate the safe, purity, no GC, and no throw. And also they don't work with qualifiers, right? So we don't see any const or immutable up there. So in order to stress it out a bit, if you have in your day-to-day work, let's say you keep an array of objects, and your task is to find a certain object in this array of objects, then you will be hit by a couple of problems. First, the opEquals operator is not able to work with const objects, right? And since this is a search function, it's pretty obvious, and it's always right the recommended way of like passing things with const. As Attila was saying earlier, this is his way of like the preferred way of doing things. The second issue is like we don't have attributes. So even though this function has no reason not to be, no throw, no GC, pure and safe, it cannot. But let's say a user is going to define his own class, improved object, that extends from object and overrides all those methods. And he adds the function attributes, but still this is not enough. So the first issue is that opCompare and opEquals, they will have to continue to take a const object instead of an improved object, and that's because of covariance. So what covariance states is that a derived class, when it overrides a method, it cannot ask for more from its parameters. It can ask for less, but not for more. The second issue is that toString has no way of meaningfully implementing a no GC version, since it has to return a string, and it has to be something of meaning to the user, so it's going to probably have to convert some runtime information. It most likely will have to call the garbage collector, or try to find some different ways. So it's pretty complicated. There are some more issues. So the first one is the object class also has a static factory method that enables you to create an instance of any class. The problem with this factory method is that it creates a lot of code bloat. In order to make it work, it needs to know the type info information of every class in your program in order to maybe call it in the future. And there aren't many calls in Phobos, for example, that actually take advantage of the factory method. So this should be opt-in at best. The second issue is this mutex field. At first, I didn't show it to you. So object has a hidden mutex field that's implementation defined, and this is used for synchronization. So when you want to ensure exclusive access in a code area and a code block, you would call synchronize, and this will effectively take this mutex. So this has a couple of problems. First, it doesn't play well with immutability and purity. There are, again, few cases where the mutex is actually used, so it should be opt-in at best, because otherwise there are a lot of classes that just take up some extra space without ever using that space. And another point is that because this is a field, it introduces a fragile base class problem. What this states is that a seemingly unrelated change in the base class could possibly lead to hard to discover bugs and breaking changes. So we want to do better. And in order to do better, actually, driving home the point is that we have 2 design goals. The first one is to allow the user, he or she, to pick the methods that his type must implement in order to best describe the behavior that his type is able to fulfill. And the second one is the root object needs to be able to work in attributed code, as it was the case with the find function. So searching for a good design, we decided to look at other languages, other object-oriented languages, and see how they treat the same problem, right? So what is the way of defining the root class, and what's the interface that this class exposes, and how do they treat the comparison, for example? So the first one that we had a look at was Java. As many of you know, D and Java have a lot in common. So object is also the root of all classes. The object in Java defines the equals, hash, and toString methods. Those are similar to opEquals, toHash, and toString, right? It has a get class, which is similar to how we use type ID on classes. And most important, it has a clone method that's similar to the factory one, and most importantly, it also has an object monitor, right? A lot of similarity. Looking at C#, though, again, is the root of all classes. C# has a much smaller interface that it imposes on the classes that extend from object. So it only has a toHash, getType, and toString. But the major difference here is that C# went a step further and removed the monitor object from the root object, and it defined it as a separate monitored instance that extends from object. So this is closer to what we want to achieve. The next candidate we had a look at is Rust. And if you are like me and don't know much about Rust, you'll probably be surprised by the next things. So the first one is Rust data types are completely unrelated. So you don't have subtyping and inheritance. The way Rust establishes relationships between different types is by using traits. So a trait is just like stating, hey, this is the behavior that I'm capable of doing. The other name that you are probably most familiar with is the traits are exactly like interfaces, more or less, right? So, and we are doing something similar with introspection and structs, right? And all the compile time features that D has. But we can emulate the same behavior with objects as well. So let's have a look at how a trait in Rust looks just for like completion, right? So you define this trait quack, it states, hey, I know how to quack. You have a struct, and then you just say, implement the quack trait for my struct. And now, yay, we can quack all day. Yeah. So now, my proposed design, well, our proposed design is, we'll have a root class that's going to be an empty object, and this is going to be at the base of the hierarchy. And we'll call this Proto Object. And then we'll define interfaces that expose the desired behavior, right? Because it can be argued that at the end of the day, you're only interested in what your type can actually achieve, and you don't have to have it baked into the object, right? So how this will look, we'll have at first a proto object, as I said, that's going to be the empty class. Then we'll have a synchronized object that will have the mutex field. So if you desire to have this mutex, then you will extend from synchronized object. And then object, as it currently is today, is going to extend from this synchronized proto object. So what this achieves is it gives us a lot of flexibility going further without creating any breaking changes. So this is pretty good. So how this came to be? Well, Andre had the following observation, as he was saying yesterday, right? So object has two roles. The first one is the root of all classes. And the second one, when you don't explicitly state what is the parent of your class, then that role is taken by object. But object doesn't necessarily have to be the root of all objects, right? So this is going to be taken care of by Proto Object. And the code will continue to work because if you don't define a parent, then we'll just leave object doing his own thing. So going forward, the recommended way is to inherit from Proto Object and then implement the interfaces that expose the desired behaviors. So in order to replicate the existing way of working with object, we start by defining 4 interfaces. Ordered, which implements the opCompare, equals for equality, hash in order to implement the toHash method, and stringify for lack of a better name, but we can vote for it, right? That exposes the toString method. So the first thing to notice with the toString is that we opted for a design that takes a delegate that you pass what you want to output, sort of like a sink, right? So this is a way of avoiding the GC problem. Now, let's talk a bit about ordering. Yeah?
Your delegate wasn't no GC?
Yeah, I tried to like make it fit the slides. Right. So, before I go into how the interface looks, I want to go through the why and what we did. And I promise this is the most complicated slide, and then we can all exhale successfully. So, first, at some point when you're going to compare two instances of a class, it's going to get lowered to a call in the runtime. And we'll compare two types, class 1 and class 2, and we don't know much about it. And we try to figure out at first what's the most derived part. So we're making an assumption at first, maybe they are somewhat related, right? Disclaimer, this code doesn't compile, right? The first alias is just like I had to fit it in the screen. So now we're looking at a bit of extra information. So we're comparing the pointers to the V table. So if the pointers are equal, then it means that we have the same dynamic type. And if we have the same dynamic type, and the dynamic type is the same as the most derived one that we've previously figured, then we can attempt and bypass the downcasting or the runtime and explicitly cast to the most derived one. So we're able to then cast to our most derived part and then call the opCompare. If we don't have this information, well, if the most derived opCompare method doesn't take another most derived, it probably takes something else, then we'll leave it to opdispatch. If we are out of luck, so either the types are of different types or they have the same type, but it's not the most derived one, then we'll leave it to opdispatch. So to dynamic dispatch. So in the worst case, when we get to dynamic dispatch, is we're going to have to compare two proto objects. We don't know anything about them, so what can we do? Well, the first step is to check if it's about the same object, and then we're done. If not, then we're going to have to do a dynamic cast to an ordered interface, and then call and leave it to the dynamic dispatch, then to a call to opCompare, and the argument is a proto object. So this is the interface. Our interface takes a proto object. The reason why it takes a proto object and not an ordered is that most likely in your implementation, you are going to do a dynamic cast from proto object to your desired type. And if we would have took an ordered, then instead of doing only one dynamic cast, you would have ended up doing two dynamic casts. So it's more of an optimization. So ordering implies that it follows a total order. What it means is that first, for any two objects A and B, only one of the following three stands true. So it's either A is less than B, or both A is equals to B, or A is greater than B. And the second one is that it's transitive. So if for three objects A, B, and C, if A is smaller than B and B is smaller than C, then A must be smaller than C. So now let's look at an example. So suppose you're implementing your class, a book, and so you'll have a unique identifier, the ISBN, and a format. And the way to compare, because a book is uniquely identified by its ISBN. You don't care about the format, right? So you just look at the ISBNs. I was surprised. I remembered I had an animation here, but apparently it's gone. All right. Okay. So as you can assume, this is going to probably generate some boilerplate for the user. And boilerplate is boring, and that's why we want to aid the user. So in order to do this, we implemented this mixin implement ordered. What this basically does, it's in the most raw form, it goes through all your fields inside your class, and it compares it with the right-hand side, right? So in order to use it, you just like mix in the template mixin, and this will automatically generate the opCompare for you, and then this is going to go through your fields, and it's going to compare them. And surprise, surprise, those are not equal. And this is the correct behavior in this current format because, as I said, you shouldn't look at formats, right? But the raw implementation will do this. So again, we thought about it. So what the next step is that it allows you to provide it with a list of the names of the fields that are significant in the ordering operation, right? So now we're telling it, hey, I'm only interested in the ISBN. And now we can see that the comparison is the right one. But there's more. What if you want to provide a custom comparator instead of using our default one, right? So we are providing you with this opportunity. Again, in the list of named fields, you can stick next to the name of your desired field what comparator you should use. And you can use either a lambda or you can give it a named function. Yeah. Got a question?
So floats don't give a total order. And if you go look in one of the scariest bits of Phobos, which is SZ typeconst proxy, you'll find that the implementation of opComp there returns a float instead of an int because it needs to return nan for cases where things are not, where in order to be where they're not orderable. And this means that you can do a proxy of a float and it works. Does this support the same mechanism? Or could it be extended to do that maybe?
So we thought about that. So just for everyone, so the reason why float is not a total order is because you cannot compare not a number, right? So nan cannot be compared with another nan. The way I would suggest going forward is kind of like replicating what Rust is doing. Got to speed up a bit. So in Rust, they have a partial order, and that's exactly for this. And it states like, hey, we're not a total order, we're a partial order, so it kind of expresses the clear intent to the user. Okay, so just to manage to go through everything, right? Okay, there can be made a case that most of the time, actually what you want to do is you want to exclude only one of the fields. So out of a list of fields inside your struct, only one is insignificant, or a couple of them. So instead of having to type all the others, you can just type the exceptions, right? So this is the final form of the super cyan here. Okay, so now, food for, what?
Did you consider using a UDA on the fields that you don't want to do that to instead of this?
No. Yeah. So now another thing is like food for thought, because you kind of went ahead of me here. So based on the same thing, so there are some classes or some types where comparing doesn't make sense, or maybe you cannot cast, right? So you cannot dynamic cast here. So from Proto Object, you attempt to dynamic cast to the book, and it's not a book. And in the previous example, you would have returned a 1 when comparing to null. Which this is kind of like you're saying, hey, I'm greater than the other guy, whereas you actually weren't able to compare with the other guy, right? Because you're comparing pears with apples. So float here would provide in with another interesting feature, because you have two options. Either you throw an exception, like uncomparable types, or you could return not a number, and this gives you some extra information. Now, equality, as you will see, the interface stemmed from the same issue. At some point, we will, in the worst case scenario, we'll have to compare two proto objects, and that's why the interface takes a proto object. Equality must respect the following contracts. So it must be reflexive, so any object must equals to itself. It must be symmetric, so if A says it's equals to B, then B must agree with this condition, right? And transitivity. And again, for equality, and in order to aid the user with all the boilerplate that he would have to type on his own, we provide the same thing. As Scott was saying a couple of editions ago, consistency, 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 right? So it implement equals has the same roles as implement ordered. And implement ordered equals except. Hashing interface, again, it's simple. It has all the attributes. There's one catch. The first is like, if for equality or comparison you can quit early, where the first time you encounter a field that's not equals to you, or with hashing you have to go through all your fields, right? So I'm not stating anything that's rocket science. I'm just like, don't forget about this. And another thing is like, because now we have a lot of power, you as the implementer, because you can decide if you want to implement the opCompare or opEquals or toHash separately, you must make sure that if you go implement each of them, they must agree. What I mean is if two objects say that they are equal, then their hashes must be equal as well. So don't forget about that. It's a common mistake in object-oriented programming. Again, for hashing, we have the same mixins that aid us. And as I said, the string takes a delegate that the delegate also needs to have all the attributes, so that I just like try to make it fit the screen. In conclusion, we have a proof of concept that it's both flexible and it's able to work in attributed code, and we have ways of reducing the code bloat that the user would have to type. So if you want to check out the dip, it's on this branch over here, and the code changes for both DMD and the runtime are also in this dip Proto Object branch on my forks. Thank you for your time, and I hope next time we meet in an elevator you won't run away. I'm here to answer all your questions.
Yeah, I think we've got basically got time for one question, so make it a good one.
Okay, one of the core problems with all the functions on object is not that it was done before we had attributes, but that no specific set of attributes is good for everyone. For instance, opEquals being const is a real problem if your object is doing any caching, because you may not, particularly if it lazily creates value, because at that point it won't have created it yet necessarily when you call opEquals, and so that object can't make it const. So why would you have interfaces here as opposed to just using templates and looking for the correct function signature?
So the best way to go with this, in my opinion, is as well to go with templates. But this is, we're trying to also improve on the lacking parts on classes and objects. So
I mean,
I know it's not a sufficiently, I don't know, good answer probably, but it's the best.
I don't see why we need the interfaces at all, because if you just have the appropriate template constraints and the code is templated, then it's a non-issue. It will work as long as the functions match up.
Well, okay. Yep.
All right.
So to answer that question, at the level, it must be understood that there is a tension between generic code using parametric polymorphism and generic code using inheritance and overriding. And at some point, you got to resolve that. You can't, if you sit down and try to do it pen on paper, you're going to realize real quick that you got to choose one or another. You can't choose both. There's no magic that templates can do that's going to undo the type erasure that occurs whenever you convert from a supertype to from a subtype to a supertype. So we chose const there because it seems like the reasonable thing to assume people are going to need. It's not expected that comparing two objects is going to write to them. And I understand that this hurts 90% of our users, but it's obvious that the other way would also hurt 90% of our users. You see my drive, right? So I think we can't have it both ways, and we chose const, and we're going to go with it.
All right, well then that's it for now. Thank you again. Round of applause, round of applause.